Our topic is population growth, and we were given a lake that is stocked with 500 fish, and the population increases according to the logistic curve. And our equation is P of t equals 10,000 over 1 plus 19 e to the power of negative t over 5, where t is measured in months.
In problem A, we use the graphing utility to graph the function, and as a result, as you can see in this graph, we got a curved graph.
In letter B, we were asked what was the limiting population for the lake full of fish, and thanks to the graphing utility, we saw that the answer was 10,000.
Then we were asked to find the rate of change of the fish population at the end of 3 months and at the end of 12 months. To do this, we have to find the derivative of our equation and then substitute the months for t. Okay, first we have our initial equation, 10,000 over 1 plus 19e to the power of negative t over 5. So first we have to put the denominator on the numerator to be 10,000 times 1 plus 19e to the power of negative t over 5 to the power of negative 1. And then with that you will do chain rule, which will give you 10,000 times negative 1, your equation between parentheses, and your derivative of the equation in the parentheses. And then you multiply 10,000 times negative 1 times the derivative of the equation in the parentheses, and then it will give you 38,000 e to the power of negative t over 5 times 1 plus 19e to the power of e to negative t over 5 to the power of negative 2, and because it is a negative power, you will put it down in the denominator, and it will give you the answer, which is 38,000 e to the power of negative t over 5 over 1 plus 19e to the power of negative t over 5 to the second power.
So by using the derivative we got on the question, we have to insert the 3 that is your 3 months. So it will be 38,000 e to the power of negative 3 over 5 over 1 plus 19e to the power of negative t over 5, and that in parentheses to the power of 2. Then you will have 38,000 e to the power of negative 0.6, because the negative 0.6 is your result of the exponent of negative 3 over 5. Then you divide that over 1 plus 19e to the power of negative t over 5, and that in parentheses to the power of 2. Then you have to multiply your answer of the exponent of negative 0.6, that it would give you 0.54881,636, and that answer you multiply it to the 38,000, giving you an answer of 20,854.842. That answer you divided over 1 plus 19e to the power of negative t over 5 in parentheses or to the power of 2. When you are finished with that part, you go to a derivative, focusing on the derivative, and you insert in the negative t over 5. On the t you insert the 3, because t is equal to 3 in this occasion. So then you will have in the derivative 1 plus 19e to the power of negative 0.6 in parentheses to the power of 2, because the answer of negative the exponent of negative 0.6 is 0.54881,636. That answer you multiply it times 19, that it should give you 10 times 10.42742,109, and that answer you add 1, that it will give you 11.42742,10,9. And with that answer you do it to the square, that it will give you 130.585952.7, and that answer it will be your delivery. Then you make 20,854.4842 divided by 130.585952.7, and your answer should be 159.70. So as the problem before, you have to insert your value of t, but in this case it will not be 3 months, it will be 12 months. So for the first step, you have to do 38,000 e to the power of negative 12 over 5. That should give you e negative 2.4. And the result of the exponent of negative 2.4 is 0.09071793. That answer you multiplied it times 38,000, giving you an answer of 3,447.282225. And all of that numbers, it should be over 1 plus 19e to the power of negative t over 5, parentheses, everything to the power of 2. When you have that, you will go to your step 4, that should be dividing your answer of 3,447.282225 over 1 plus 19e, and inserting in the t your value of 12, that should give you e negative to the power of negative 12 over 5, in parentheses everything to the power of 2, and the result of the negative 12 over 5 should be negative 2.4. So it will be e to the power of negative 2.4, and giving you as a result of the exponent 0.09071793. And all of that answer you multiply it by 19, that should give you 1.7236411,107, and that then you add 1, that it should be 2.7236411107. When you have that answer, you do it square, that it should be 7.41822088. And all of that answer, it will be your derivative. So at the end, your final step is to divide 3,447.282225 over 7.41822088, and your answer should be 464.70.
In problem D, they ask us at what point in the graph does the population rise at the most rapid rates.
As we can see in the graph, which is the derivative of the original problem we were given, has a absolute maximum at 500 and has an absolute minimum at 0.